So now let's use some ratios to help solve problems. Here's a sample. Members of the drama department are planning a fundraiser for Valentine's Day. They'll be selling white carnations and red roses. They hope to sell more red roses than white carnations, probably because the roses are more expensive, but we don't know that. And they decide to purchase 3 roses for every 2 carnations. Hopefully they'll sell 150 flowers total, so how many of each type should they purchase? Remember, the ratio of white carnations to red roses is 2 to 3. Now keep in mind, that ratio has been reduced to lowest terms. So it could have been 6 to 9 times the top and bottom by 3, or 20 to 30 multiplying top and bottom by 10. But actually it's probably much more than that. We don't know what number was reduced out of the ratio, so let's just call it 2x to 3x. And that x is what we reduced. Something else that we know is that both of these numbers combined have to equal 150. So that gives us the equation 2x plus 3x has to equal 150. The number of white carnations plus the number of red roses is 150. And solving that, 2x plus 3x is 5x. Divide both sides of the equation by 5, so we find out that x is 30. To find out how many flowers of each type we get, we just simply plug in 30 to each of the expressions. So white carnations is 2 times 30, which is 60. And red roses is 3 times 30, which is 90. Of course, we can quickly check to see how well we've done. By taking 60 plus 90, we get 150. So it looks like it works out fine. So we should get 60 white carnations and 30 red roses. Now for our next example, we are going to need to know what we mean by an extended ratio. An extended ratio is a ratio comparing 3 or more numbers. So an example of that would be A to B to C. Extended ratios are a combination of 3 or more other ratios. In this extended ratio, the 3 ratios are found by taking the first 2 numbers, A to B, the last 2 numbers, B to C, and the first and last number, A to C. These are actually the 3 ratios that were combined to create this single extended ratio. So here's an example using the extended ratio. In this triangle, the lengths of the sides of the triangle are in the extended ratio 2 to 5 to 8. And the perimeter of this triangle happens to be 291 meters. What is the length of the shortest side of the triangle? Just like the example with the flowers, this 2 to 5 to 8 is a ratio that's been reduced to its lowest terms. We reduced out some number y. The actual original ratio was something like 2 times this y to 5y to 8y. That means the 3 sides had lengths of 2y, 5y, and 8y. The thing that we know about these 3 numbers is that all of them added together have to be the perimeter of the triangle. So 2y plus 5y plus 8y equals 291. And from there, it's just some simple algebra. If we add these 3 together, 2 plus 5 plus 8 is 15, and 291 divided by 15 is 19 4/10. So now we know what y is. To find the length of the shortest side, well, is that going to be the 2y, the 5y, or the 8y? It's kind of a no-brainer. It's going to be the 2y. So to find the shortest side, we simply plug the 19 4/10 into 2y. So 19 4/10 times 2 is 38 8/10 meters.